Today we're solving inequalities. We talked about inequalities yesterday. You understand what they are. It's just comparing two numbers. Now you're going to solve the inequalities, which what I tell students is that when you solve an inequality, it's exactly the same as if you were solving an equation that had an equal sign. You treat it exactly the same, except for two cases, which we will talk about later today. All right, right now, you treat it just like that's an equal sign. So you draw a line through it, and you're trying to figure out what x needs to be, or what the lowest number x can be to make this true statement. So x plus 5, I'm adding 5, so I would subtract 5. X is greater than 7. You just write that. That would be your answer. Okay? This is just like when we had something like this, which you don't have to write down, but you see this, right? X is 2. When you solve for x, you get 2. 2 is the only number that makes this a true statement, right? No other number, when you add 3 to it, gives you 5. Okay? So that x can only be one number. When you work with inequalities, though, we're not looking for one number. We're looking for a set of numbers. Okay? Which here, 7, okay, is kind of the minimum, right? Like, as this says x is greater than 7. So it means anything that's bigger than 7 makes this a true statement. Like earlier, 2 was the only thing that made a true statement. This is a set of numbers. It can be a whole bunch of numbers. You just have to know what's included and what's not included. 8 would make this a true statement. 9 would make this a true statement. 10 would make a true statement. And you should always check your homework. You always should check your answers. So plug in 10 because 10 is greater than 7. What's 10 plus 5? 15. Is that greater than 12? Yeah, that makes it a true statement. So that means any number bigger than 7 makes us true. So that's what we need. So we're trying to find a set of numbers that makes us true. Instead of just one number, it's a set, which is anything bigger than 7 in this case. All right, write this one down. Here you have y plus 10 is less than 3. We're trying to figure out what y is. We're solving it just like if there was an equals line. We're going to try and get the variable by itself. I'm adding 10 to it, so I do the opposite. I subtract 10. Y is less than negative 7. Which I should check my work. What is a number less than negative 7? Negative 8. I like negative 10 because it comes out easier. What's negative 10 plus 10? 0. Is 0 less than 3? Yeah. Yes, so that makes it a true statement. This must be your answer. Here I have 3 is less than or equal to b minus 1 1/2. So my goal is always to get the variable by itself. So I look at what's being done to b. I'm subtracting 1 1/3. So I'm going to add 1 1/3. Which would give me 4 1/3. Which is less than or equal to b. Now it may want you to graph it. After you graph it, okay, easy to graph. We did it yesterday. But I'm showing you this one just because you might get confused with 4 1/3. Put 4 here, put 5 there. Okay, and go a third of the way between 4 and 5. So it would be like right there. That's a third of the way. It said 4 1/3 is less than or equal to b, so it needs to be a closed circle. And b is anything bigger than 4 1/3, so it goes to the right. So anything on this side of the arrow, on the right side of 4 1/3 is going to make this a true statement. And you can check if you want. Okay, let's do 5 1/3. What's 5 1/3 minus 1 1/3? 5 1/3 minus 1 1/3. 4. Is 3 less than or equal to 4? Yeah, so I must have done it right. Okay, everybody get it? Pretty easy, right? Alright, write this down. Okay, the reason this slide's up here, okay, there's a reason for it. Okay, earlier they have a slide, like they have a thing like this in the notes in the book for addition, subtraction, right? But I don't really feel it's necessary because we kind of worked on it yesterday. All right, you just treat it like it's equal sign, solve for x, no big deal. But I told you there's two cases where it's not the same as if there was just an equal sign. Right? One of them has to do with multiplication, the other has to do with division. Right? And what they do is they just give you letters here, and they show you what's happening to those letters. Right? If you don't understand what's happening to those letters, replace those letters with numbers. That might make sense to you. So here they've got A is greater than B. Well, if that doesn't make sense to you, you could replace A and B with numbers that do. Let's say that's 3 and let's say that's 2. Is this a true statement? 3 is greater than 2? Yes. Yes. Well, what this says is if AC, which means you times A with C, okay, and once you do the one side, you have to do the other, right? Okay, that's a rule. We know that. What you do one side of the sign, you do the other. AC is greater than BC if C is positive. If C is greater than 0, then your sign doesn't change. See how they're the same sign? So let's say C is 2. 3 times 2 is 6. 2 times 2 is 4. Is 6 greater than 4? Yes. So nothing changed. The way it's different, and what I've been telling you it's different, is the case where C is negative. If C is a negative number, if C is less than 0, here A is greater than B, but you see the sign has changed. This sign is opposite of that sign. Because when you times by a negative number, you have to flip your sign to keep this a true statement. Which again, it's going to make more sense in a minute. I'm going to show you some examples of it. Okay, but Lynn, let's go back to this. 3 is greater than 2. That's a true statement, right? Well, let's say I multiply by negative 1. Is that a number that's less than 0? Yes. What is 3 times negative 1? What's 2 times negative 1? Okay, if I was to keep this sign and put that right there, the greater than symbol, would this be a true statement? Negative 3 is greater than negative 2? No. No. So the only way it remains true is if I flip my sign. Right? So if I multiply by a negative number, you have to flip your sign to keep it true. Alright, and write this down. These are the rules for division. Division has the same rules as multiplication. Here A is greater than B, and when you divide both sides by C, if C is positive, you don't change your sign. Nothing changes. A is greater than B, and A divided by C is greater than B divided by C. If you're not for sure, if that doesn't make sense, plug in numbers you know. Go like 6 and 4 and divide both those by 2. Right? You'll get 3 is greater than 2. That's still a true statement. The difference in the other case I've been talking about, where it's not the same as if there's an equal sign, is if you divide by C and C is negative. If C is less than 0. You have to change your sign to make this a true statement. Let me give you an example. Let's go with 6 and 4. Is 6 greater than 4? Let's divide by negative 2. So 6 divided by negative 2 is negative 3, right? 4 divided by negative 2 is negative 2. If I kept this sign, would this be a true statement? Negative 3 is greater than negative 2? No. The only way it remains true is if I flip my sign. That's the only way. When you multiply and divide by negative numbers, it's the only time it's different than the equal sign. The rest of the time, nothing changes. You just drop everything down and follow along. Your sign stays the same. Okay? Nothing changes. But when you divide or times by a negative number, you have to remember, oh, this is a little different. You got to flip your sign. Okay? If you don't, you're going to get it wrong. But here's the nice thing, is you can always check your answers on these. So if you check your answer and be like, man, that ain't right. Well, think, did I flip my sign? Was I supposed to flip my sign? If you didn't flip your sign, you probably should have, right? All right, let's solve this one. Negative 5x is less than 45. I'm trying to get x by itself. I see I'm timesing by negative 5, so I would divide by negative 5. X drops down. 45 divided by negative 5 is negative 9. Here the sign is less than. So what does the sign at the bottom need to be? It needs to be greater than. Why does it need to be greater than? William, why do I change my sign down there? because I divided by a negative number, right? Well, let's check, see if this is right. What's a number bigger than negative 9? Negative 8. I like 0. If you can use 0, use 0. Hey, what's negative 5 times 0? Is 0 less than 45? So this must be right. You must have done it right. Now, what I'm going to do, you don't have to write this down, but pay attention, is I'm going to do it backwards and I don't flip my sign. So negative 5 divided by negative 5 leaves me with x. 45 divided by negative 5 is negative 9. And let's say I forgot to change my sign like Ben did. He said it was less than. He said it needs to be less than. Ben, what is a number less than negative 9? Excuse me. Negative 10. All right. So let's plug in negative 10 and see if this is your statement. Negative 5 times negative 10 should be less than 45. Let's see if it is. Negative 5 times negative 10 is 50. Is 50 less than 45? No. So if Ben had checked his answer and seen this, he would have known that ain't right. I did something wrong. And then looked, oh yeah, I never flipped my sign. And he would have flipped his sign and got it right. Okay? Make sure you pay attention to that. If you divide by a negative number, or if you times by a negative number, you flip your sign. Alright, write this one down. Here they give you b is divided by negative 8, which is greater than or equal to negative 6. Your job is to figure out what b is that makes this a true statement. And there's a few problems where it asks you to graph on a number line. So we're going to do that just to make sure you understand. b is divided by negative 8, so I would times both sides by negative 8 to undo that. b drops down. What is negative 6 times negative 8? Huh? What is it, Alan? 48, good. Sierra, my sign at the top is greater than or equal to. What does it need to be at the bottom? Less than or equal to, good. Okay, if this sign has an equal to, the line underneath, then this sign has to have it. The problem before, it didn't have it. So that didn't have it. But if it has it, it keeps it. Okay? It will always be or equal to. Right? If it's just less than, then it's greater than. If it's less than or equal to, when you flip it, it's greater than or equal to. The equal to stays. Alright? Now, let's graph this. b is less than or equal to 48, so I put a dot at a closed dot at 48. And it says b is anything that's less than 48, so I'm going to just draw a line going to left because all of those numbers are less than 48. Now you can plug in any number you want that's on that arrow, including 48, and this will be a true statement. We think, right? Have we checked it? No, so we're not for sure. Let's check it. What's a number less than or equal to 48?
47.
Okay, yeah, 47, but I like 0. What's 0 divided by negative 8?
0.
Is 0 greater than negative 6?
Yes.
Okay, 0 is greater than or equal to negative 6, so that's a true statement. Right? If you go with 47, do you know exactly what 47 divided by 8 is? No, you're going to get decimal or fraction and a little bit harder to work with. Okay, I would pick numbers that would come out even, right? Which I always go with 0 if it's possible, right? Okay. If 0 is on that arrow, I'm picking it. Why not? That's easy. Any questions how to do that? You guys get it now? Makes sense?
Yep.
Here it says 7 is greater than negative 2f. I got to get f by itself. So I divide by negative 2. 7 divided by negative 2 is negative 3 1/2 or 3.5. Okay. Sometimes the book goes decimal, sometimes it doesn't. Make sure you pay attention to what it's asking for. What would be my sign? If up here it's greater than, what does it need to be now? Less than. We've got to change it. So negative 3 1/2 is less than f. And that would be my answer. Right? Which if you want to pick a number what would be a number that's less than negative 3 1/2?
0.
That's less than negative 3 1/2. Be like negative 5, right? Okay. So let's go with negative 5. What's negative 2 times negative 5?
10.
10, right?
Oh, negative 2, yeah, 2.
Okay. So 7, which hold on, that doesn't seem right. Never mind, we were supposed to go the opposite direction, right? What is a number bigger than negative 3 1/2? 0, right? What is negative 2 times 0? 0. Is 7 larger than 0? Yes, so that would be a true statement. I was looking up here and thinking down here. All right, easy enough. Any questions? All right, one more. All right, I want you guys to work this one. Negative 2 is less than 2a, so I divide by 2 to get a by itself. Negative 2 divided by 2 is negative 1. My answer is negative 1 is less than a. Let's see what your answer is. Okay. I'm guessing that you got negative 1 is greater than a. Okay? Most of you probably got that. Here's why it's wrong. My rule said that if I times or divide by a negative number, then I flip my sign. Is 2 a negative number?
No, I see where I
2, the number I divided by, was that a negative number? No. The number I take from one side and move to the other, I only change the sign if it's negative. It does not matter what this number is. Does not matter. Is this number doing the dividing? Am I multiplying by negative 2? No, that's the one that's getting multiplied to, right? Not by. It's the one that you're moving to the other side. Here I divided by 2, which is a positive number. Do we ever change the sign when we divide by a positive number?
No.
No. Do I ever change the sign when I divide by a negative number or positive number? No. I only change the sign if I divide or multiply by a negative number. Does that make sense? Does not matter what the original one is. Okay? Everybody get it? All right, here's your assignment for today.